So these questions I've just dropped them on assignments group that concerning what we just finished, specifically on what we just finished. All these resonance stuff, open pipe, closed pipe, harmonics, overtones, strings. So these are the questions. I've just dropped 22 questions. So the previous video I made was just solving questions generally on sounds, but this one now is to focus on the part that we just finished. That part I feel is more complicated than every other thing generally in sounds. Do you understand? So that's why we're having the second video. Okay, so I'll also be uploading it on YouTube as well. All right, let's go. A pipe closed at one end is 1.0 meter long. The air in the pipe. So, by the way, this one I've already screenshotted them, so there's no way for me to see my school's answer. So, I'm just going to be solving them and giving you my own answer. Okay. So, a pipe closed. So, I especially going to select those questions that we need. That's what I did. I screenshotted the questions that we need. Okay. So, a pipe closed at one end is 1.0 meter long. So this is a closed pipe. The air in the pipe is set into vibration and a fundamental note of frequency 85 Hz is produced. Calculate the velocity of the sound in air. Calculate the velocity of the sound in air. So neglect end correction. So you should ignore anything end correction. So let's go. They've given you the length of the pipe. They've given you the fundamental note. It's velocity they're asking you for. Now this is a closed pipe, remember, right? This is a closed pipe. And what's the formula for fundamental frequency of a closed pipe? F equal to V over 4L. Math editor app. So, so we have F equal to V over 4L. So they've given us F, that it is 85 Hertz. Am I correct? Yes, 85 Hertz. So 85 equals to V. That's what we're asked to get. Over 4 times L. L is 1 meters from the question. So times 1. So this is 85 over 4 basically. V over 4. Cross multiply, you have that V is equal to 85 times 4, which will be 340. 340 meters per second is the answer. So option A is the correct answer to that. Question 2. The wavelength of the first overtone of a note in a closed pipe of length 33 centimeters is. Now, remember closed pipe, your overtones are taking odd number multiples, right? The first overtone is 3 times the fundamental frequency. The second overtone is what? 5 times the fundamental frequency, and so on and so forth. Remember, so it's odd number multiples. So they're asking for the first overtone. They're giving you the length of the pipe, that it is 33 centimeters. They're not even asking for the frequency. They're asking for wavelength. They're asking for wavelength of first overtone. Do you understand? So if you've this gone through the class on Telegram that I've taught completely, and you followed how I derived the formulas for frequency in first overtone, frequency in second overtone, and so on and so forth. I first started with getting a formula for wavelength. Yes, that's how I started. Do you get me? I started with getting a formula for wavelength first of all. So I got wavelength under fundamental notes. I also got wavelength under first overtone, wavelength under second overtone. So let me just go and write them down. Or I think I should even go to the Telegram class right now and show you exactly what I mean. Let me go to the Telegram class and show you what I mean. So lecture ground. Thing is, I explained them in a video. But I also sent some pictures that carried some formulas. Okay, so you see this picture right here. It's about closed end. So you see this L equal to 3 over 4 wavelength. That wavelength 1 is the wavelength in first overtone. You see this one is L equals to 5 over 4 wavelength 2. That's wavelength in second overtone. So we're using this one that is L equal to 3 over 4 lambda 1. Do you understand? So that's what I'm using there. So let me save this particular question. Saved. All right, go back. Nope. Discard. So L equal to 3. Is it 3 over 4 or 4 over 3 that we saw that time? It's 3 over 4 wavelengths. So equal to 3 over 4 of the wavelength. So we also, while in the videos I sent in Telegram, I derived the form just to rearrange this thing. You have 4 over 3 4 over 3 L, right? You add 4 over 3 times L. So an L is 33 centimeters. So our wavelength is basically 4 over 3 times 33. 33 was given to us in the question. So 3 in 33 is 11. So I have that my wavelength is equal to 4 times 11, which will be 44 cm. So 44 cm is my answer. That will be the wavelength of the first overtone. Now to go back to the assignment group where I dropped the questions. That was question 2. So 44 cm, option B. Next question. A pipe open at both ends, produces a fundamental note if the velocity of sound in air is v and length of the pipe is l. Which of the following expression expresses the frequency of the note? That's the fundamental note now. The frequency of the fundamental note. Neglect end correction. So this is an open pipe situation, and fundamental note frequency, from what I taught you, is what? V over 2L. V over 2L. Option B is the answer. If it was closed pipe, it's V over 4L. But since it's open pipe, it's V over 2L. Are we clear on that? Alright, move on. In a closed organ, pipe producing a musical note, an antinode will always be produced at closed organ pipe, meaning that one end is closed, the other end is open. Okay, so the antinode, you always be where you have maximum vibration, where there's freedom, that's at the open end. I said it a lot of times while I was teaching this thing. The open end is the antinode, the closed end is the node. So the open end, option D, is the answer. A pipe of length 45 cm is closed at one end. Calculate the fundamental frequency of the sound wave generated in the pipe if the velocity of sound in air is 360 meters per second. They said neglect end correction. So they've given you the length, they've given you the velocity, they're asking you for the fundamental frequency. And this is a closed pipe. They said it's closed at one end. That's V over 4L, what we just discussed now. V over 4L for closed, V over 2L for open. Okay, so V is 360, L is 45. So that is saved. Go again. So V F is equal to V over 4L. So the V they gave us is 360. Duplicate. The V they gave us is 360, and the L they gave us is, I think, 45, right? 45, yes. So 4 times 45 is 180. So this 360 is 360 divided by 180, which will give us 2. So our frequency is 2. But let's just hold on. The length they gave us 45 centimeters, so I was wrong. 45 centimeters is the same thing as 0.05 meters. 0.45 meters rather, because see, the velocity they gave us was in meters per second, the length 45 centimeters. I have to convert that 45 centimeters to meters, so that's 0.45. Okay, so 4 times 0.45 is 1.8. 1.8. So when I divide this thing, I'll have 200 instead. So 200 hertz is my answer. How did I know I was wrong? frequencies of sound are usually higher than 2. It's not usually in tens, it's usually in not usually in units, it's usually in tens and hundreds. Just have that at the back of your mind. That's the range of frequency that we can hear. Okay, so just have that at the back of your mind. So that's how I knew that when I got 2, I said, this frequency looks too small. So I had to check my units. You get. Alright, so 200 hertz is the answer. What am I writing, Seth? So 200 hertz. Next question: an organ or an organic pipe. Organ, when you talk about organ instrument, that's the one you blow into. An organic pipe closed at one end is 80 centimeter long. Determine the frequency of the fundamental notes, assuming that the speed of sound in air is 340. So it's just exactly like the same thing we just solved now. They're giving you velocity, they're giving you length. And again, this length is in centimeters, so we have to change to meters. The same formula is a closed pipe, it's still V over 4L. So we do the same thing, but this time the velocity they gave us is 340 and the distance they gave us is 0.80. So 4 times 0.80 is 3.2, right? Yes, that's 3.2. 3.2. So 360 divided by 3.2, that's 112.5. So that will be the frequency here, 112.5. So save this. All right. So what? I didn't get my answer. 340. Uh-huh. An organic pipe closed at one end is 80 centimeter long. 4 times 0.8 is not 3.2. Let me confirm that math. 3.2. Then 340 divided by 3.2. Oh, 106.25. How did I not get the other thing? What was I writing? Oh, I was still working with 360 here. So instead of 340. Just to have worked with 340 here. So that's 340. So we have 106.25. Alright, so that's the answer. So option A is the correct answer there. Next question: if the fundamental frequency of a closed pipe organ on a day when the speed of sound is 340 is 170 hertz, then the length of the pipe is, okay, if the fundamental frequency, okay, they're giving you the fundamental frequency at 170, they're giving you the speed at 340, so that's why the length of pipe is still a closed pipe, right? So it's still F equal to V over 4L. So we'll stick to use the same formula, but this time around is the length we're asked to get. So let me just clear this particular one. So still the same formula, F naught equal to V over 4L. So they're giving me the frequency as 170. They've given you the velocity as 340. Now it's L that you don't know. That's 4 times L. So 340 divided by 4. What would that give us? 340 divided by 4 is 85. So this will be 85 over L. This will be 85 divided by L. Then you cross multiply, you have 170L equal to 85. Divide both sides by 170, you find out that L is equal to 85 over 170. So you find out that L is 50 centimeters, 0.5 meters, 0.5 meters or 50 centimeters. So 50 centimeters is the answer, 0.5 meters. That's option A. Alright, question 13. Which of the following statement about waves in pipes is correct? For open pipes, there's only one end correction to be accounted for. No. If there's open pipe, that means both ends are open. You take end correction on both ends. If it was closed pipe, you take end correction on only one end. So option A is wrong. It's not only one end you take correction for in open pipe, you take correction in two ends. Option B is also wrong for the same reason. For closed pipe, you take correction in only one end. Option C, only odd harmonics are possible in closed pipes. Correct. Closed pipe has only odd harmonics, but then in open pipe, every number 1, 2, 3, they are there. Then all harmonics are possible in closed pipes. That's wrong. It's all harmonics are possible in open pipe. All harmonics are possible in strings, but not all harmonics are possible in closed pipes. For closed pipes, it's only odd harmonics. Okay. Next one, a pair of musical instrument that works on vibration of air in pipes. Piano is string. Take note, piano is string. Organ is air. So both option A is wrong. We're looking for both of them that will be air. Guitar is string, flute is air. That's wrong as well. Trumpet is air, violin is string. That's wrong as well. Option D is the correct answer. Flute and trumpet, both of them use air. Question 16. Which of the following statements about the third overtone of a vibrating air column of an open pipe is correct? Third overtone. Third overtone. Right? Third overtone. So the first one says it has 4 nodes. Now let's understand third overtone of an open pipe. Third overtone of an open pipe. Now let's check what I sent on the group. See the summary I dropped on the group when I was teaching all these things. Where's that my summary? After all the videos I sent, I gave a summary. For an open pipe, your first overtone is twice the frequency. Your second overtone is 3 times the frequency. You can see it here, right? Your third overtone is 4 times the frequency. That's your fourth harmonic, and so on and so forth. That's how open pipe works. And remember, we derived all these things from. I still there. So, we derived all these things from what's it called? The wavelength. We first got wavelength before we got these frequencies. We first got wavelength before we got all these frequencies. Now, I don't know if I can open any video, particular video I used to explain these things. I don't know if I can open the videos, but then let me just give you the formula. All right, let me just give you the formula. Let me just exit and open a new one. Okay, so when you're talking about the first overtone, the wavelength. Sorry, yes, the wavelength was how would I put it? For the first overtone, the wavelength was